what is really happening in any industry. So you will have a clear idea what is really happening in any manufacturing industry or any type of industry that may be. So let's continue yesterday's flow. Let's discuss more about different other charts as well as with some few example. Okay, with a real example we will show you how we make different types of chart and what is the importance, what are the different guidelines, how with few example, real example, you can have a clear idea how this type of chart is made. So now at the starting of today's class, we will discuss more about process chart. So here it is an example how we can make a process chart. So in this slide, if you can see, it is a process chart but material type. Okay, and suppose for an this is a process of galvanization of an article. This is under workshop. The department is written workshop. So at the top of any process chart, you have to write down in a default format about the industry or about the field where this process chart actually will work. Okay, then what is the parts, then some batch code and different code will be written there. Then who will make this chart, by the here charted by, that people name will be there, then at which date. Okay, so then there are different symbols and its explanation we need to write it here. So yesterday and the previous classes we have told you that there are different symbols which show you different things, like this arrow type symbol, it shows you the movement, transportation. Then this circle type, this symbol indicates some operation is going on. Then again this triangle, it means there is some hold, means some delay, not delay actually, this is some hold, means now the system will be hold for few minutes, that may be due to maintenance, that may be due to other operation. Then this rectangular box, it is, you can say, some inspection. And a d type symbol is again, it is there, it is uh, mean to be some delay. Okay, and by this triangle it is also where the finishing part or some holding position, some stored position. Okay, so here in this process chart, if you can see plus this arrow symbol, it is written that bring the article by cart into workshop. So this is beginning of the process. We need to bring our work material, raw material to workshop. So this is a movement. Whenever you will see this arrow type symbol, you will need to remember that there is some transportation, movement of material, movement of machines, movement of any other things is there. Okay. Then next is this circle. Here it means clean the article with some operation. You need to clean the article, clean the raw material, or clean at the clean the part which need to be machine or which need to go through the process. Next again another movement, article to the galvanizing tank. So here is an example, because it is a galvanization, this process is galvanization of article. So here means some process is going on, article to the galvanizing tank, not process. This by this arrow means there is some movement, article of the galvanizing tank. So we will take the article, then we will clean it, some operation, then again some movement, then again some operation. These three operation, altogether these three operation will be done one by one. First is connect the article to the rope hoist, then dip the article into the molten zinc, then get the article out from the molten zinc. Means we need to take this article and place it to the galvanizing tank, and the related process, related operation which will be done in that galvanizing tank, that will carry out. So these three circle means there are three different types of operation is going on. So you should remember that. Remember that if there is some triangle means some movement, if some this circle type means some operation is going on. Then this triangle type means there is some hold, or you can say some no movement, no operation. So hold the system to drain out the excess zinc. So in this process, after galvanizing, there is some excess zinc is there. So we need to wash out, or we need to drain out all the excess material. So for this purpose, this step. Then again, after all the excess zinc is drained out, then we again need to take this to another uh, system, or another process which is known as for cooling place. So here article to cooling place means some movement. So you should remember that this arrow sign means there is some movement is there. Then another two circle. So if you can see that this is a sequential process, one by one we need to follow. And what type of process, whether it is move transportation or movement or some operation or some holding, some delay, all you can understood by this symbol. So after you take this article in the cooling place, then some two operation will be there. Place the article to cool down, remove the rope hoist. So two operation is there. Then again another movement, after cooling of article, bring it for sawdusting. Then after this movement, then again sawdusting process will be carried out. Then it is done. Is this symbol means there is some operation is there. Then again some movement, moving the article for inspection. Then this rectangular, another new symbol, it shows that some inspection will need to be there. You need to inspect whether the process is correctly going on, the material or what the equipment is in the correct position or not. For that some inspection is needed. Then after inspection, we need to load this article into the cart, the process. And again, after all the process has been done, article need to take to the storage, to the inventory. Okay. Then again, next process is stored, means some hold. So in this way, we will need to make our process chart. So in exam, there are some exam question may come that explain a process chart with a suitable example. With a suitable example means you need to, in this way you need to explain the process through which your material, your article, your raw material will go through, and from the beginning to end, what are the different process, whether it is movement, whether it is some operations, or whether some delay or store, whatever that may be, with the required symbol you need to explain it, you need to explain your process chart. Okay, so this is just an example. Through internet you can find many others, and also if you can understand all the process chart, you can make your own process chart. So next, machine equipment. Machine equipment flow process chart. So here machine or equipment flow process chart is shown. One example, it's a real example, you can say that a machine or an equipment, how it flow from where to where time to time it need to move. And for that, what will be the process chart, how you need to indicate. So this is a machine or equipment flow process chart where it is written flow process chart. And what is the job? Requisition of petty cash. So petty cash, what are the finance, the cash is needed, how it will flow, that it is showing here with this flow process chart, right? So if here if you can see some some operations, some movement, then some inspection, delay, storage, and how much distance it will move, all these are indicate here. So if we see that in operation, see in this way with a circle it is indicate that all are some operation. And then movement, this arrow, movement or transportation. Then for inspection we indicate with a rectangle. Then with a D type symbol we indicate the delay. Then with a triangle we indicate say there is some storage or there is some hold position. So just check this requisition made out by department head. It's some operation. This is some operation. We department head will decide how much cost it will need, how much cash it is needed. So that requisition they will make here. So some operation. Then from that cash will go to delay, that put in pickup flag. Means after you request, after you filled your requisition, then there will be some analysis, and allow, and for that some there is some time delay will be there. So it is showing there time delay, this. That's why from here that cash will come to this delay position. Then next is to accounting department. So whether after some delay there some analysis is going on, after that they will send to the accountant department, okay, for more further process. So means that requisition, that details that will move to accounting department. That's why some movement is there. So how much move? 10 meter. So it is due to petty cash. It may looks like that why movement is needed, but you can think it as a another machine also. Then the process will be, the detailed process will be different. Okay, so this is just an example. After this movement, then it will go for the accountant and for signature verification, another verification. So some inspection will be there. That's why from this point it will come to some inspection movement, and from inspection movement it will come to some operation. Three operations will be there. Continuous 3 4 continuous operations will be there. So what are the operations? Amount approved by treasurer. After verification, after analysis, the amount is approved by the treasurer. Okay, after the treasurer approval means some operation is going on, and then it will the amount they approved by the treasurer. Then next is cashier. So amount counted by cashier. So cashier will count whether the amount has been provided, whether it is correctly provided or not. So that he will count. So that's why it is again another operation. Then amount recorded by the bookkeeper. So next after cashier, that flow, that how much money is providing and whom you are given that money. So all this record will be kept by the bookkeeper, right? So another operation will be there. Then petty cash sealed in envelope. After bookkeeper recorded the amount, then it is given to the envelope, or you can say nowadays it will give to the, for movement it will send to the bank, the requisition. So another operation will be there. Then again PT cash carried to department. So it means there is some movement after cash is ready, so it will need to handed over to the department. So some movement. After that, PT cache checked against requisition. So after the department take the cache, they will scrutinize, or they will check whether the requisition, how much requisition they have provided, whether the same amount has been collected or not, or if there is any small amount, they will check. So that's why PT cache checked against requisition means some inspection will be done by the department. So from that, it will again move to some operation. Receipt sign means department will sign that yes, they got the money. That receipt they will give. So some operation. Then again, that receipt signed, it will go to the department account. PT cash stored in a box means it will handed over to the department cashier means it will kept some places, some storage, and after that when needed from this storage they will take and they will use. Okay, so here all the details method, details process you need to write, and whether that is a movement, whether there is some operation, storage or inspection, that we need to indicate through this line. Like this way we need to indicate that, and accordingly at the end we need to give some summary, like how much operation will be there, how much inspection will be there, see, if you can see how many operations, six, 1 2 3 4 5 6, so six operation is there in this equipment or machine flow chart. Okay, then inspection, two inspection. Then whether there is two inspection, or let us check. There is one and two. So two inspection is there. Then again transport two. Let us check. This is sorry inspection. It is inspection, right? This is rectangular. So here one and two. This two inspection is there. Then transport. Transport means movement in arrow symbol. So how many transport or movement are there? One, two. Same way it is written two. Then delay is one. And total distance moved 10 plus 5, 15. So total 11 methods or 11 operations you can say, including inspection, transportation, delay, and it need to move 15 meter. So this is a machine or equipment flow process chart. So I hope you have understood this machine and equipment flow process chart. If you have any question, any query, you can ask me regarding this machine or process chart. Any question? Okay. I think there is no question. So we'll move to next. So next our another new chart we will see, which is two-handed process chart. Two-handed process chart or right hand left hand chart. So what is this? We already in a summarized way we have discussed it. Now in details we will see here in this coming slides. So two-handed process chart, or you can say right hand left hand chart. What is that? It is the process chart in which the activities of two hands of the operator are recorded. So previously, whatever the chart we have discussed, we have shown you. In that, all the chart were related to machine, equipment, or flow of your raw material, etc. So now in this chart, we will see how the operator, who is actually a human being, how his two hands, from the name itself, it is written two-handed process chart, means how or where or what are the types of work will be done uh, by the two hands of that operator. That details will be recorded in 200 process chart. Okay. So motion of both hands of worker are right hand, left hand chart recorded independently. So here as we all have two hands. So here also movement of our two hands, that uh, our means, suppose you are a worker, I am a worker. So our a worker two hands movement will be recorded independently. Means independently means at the same time we will record what our left hand is doing, what our right hand is doing. So this type of chart, it shows whether the two hands of the operator are idle or moving in relation to one another in a time scale. So this process chart will show us that whether one hand is idle or working compared to other hand in a particular time period. That's why it is written. It shows whether two hands of the operator are idle or moving in relation to one another in a time scale. So it is generally used for repetitive operations. When we need to do some repetitive operation, some batch type production, where same type of product we are making in numbers. So repetitive operations we need to do. For that, those cases we use 200 process chart. Next, uh, in details, some operations represents the activities, grasp, position, use, release, etc. of a tool, component or material. So here again, all these uh, features like operation, transport or movement, delay, storage, all these inspection except this inspection except this inspection activity, all other activities will be recorded. So using operations means it will represent the activities grasp. What are the activities doing by our two hands? Then what is its position? What is the use of that hand? How when they are releasing it? If suppose some you are holding something, then when you are moving it, when you are leaving that holding of tool or maybe machine or maybe in any other component, so all those things will be recorded. Then transport, it represents the movement of the hand or limb to or from the work or a tool or material. So our hand movement is there. Sometimes hand is moved to take the tool or sometimes to leave the tool, sometimes to take it and return it back. That may be tool, that may be equipment, that may be the machine, or that may be for a workpiece. So that transport, that movement is recorded here. Then next activity is delay. It refers to the time when the hand or limb is idle. Suppose sometimes what happen, our right hand is working and left hand is no, don't need to do anything. It is kept idle. So there will be a delay by the left hand point of view, left hand end, right? Then some storage. So the activity storage or hold means the term hold is used here instead of storage. This refers to the time when the work is held by hand. Means the when we use two-handed process chart, that time we don't use storage activity. Instead of that, we use the term hold. Sometimes we need to hold our workpiece. Sometimes we need to hold our cutting tool or equipment. So that time period will be recorded using this hold activity. Then another activity which we have seen in our previous process charts, which is not available in 200 process chart, which is inspection. The activity inspection by hand is considered as an operation. Hence, the symbol for inspection is not used in this chart. So if there is some inspection has been done by our hand, we will call it as a operation. That's why we don't use inspection activity. Instead of that, we use it as a operation. So that's why this inspection activity, that symbol we don't use in 200 process chart. 200 process chart can be used for assembly, machining and clerical job. So whatever the our hand two hand do, we can record that using 200 process chart. It may be for assembly purpose, it may be some machining purpose or some clerical job. Okay. So the objective of this type of investigation or this type of chart is to eliminate or reduce the unwanted motion and to arrange the remaining motions in a best sequence. If we have a clear idea how our hand is moving by using 200 process chart, then what we can do after analyzing that chart, we can reduce or we can say we can eliminate if there is some unwanted movement of our hand. Because when some process is going on, when you are or a worker is uh, st- uh, standing in front of a machine, okay, and machine is running and your process is going on, then if there is some unwanted movement of our hand, then it may cause some disturbance in the machine. It may cause some uh, error in the workpiece, the equipment, or also it may act as a risk for the operator. Because suppose due to unwanted movement the hand is touching the machine. Suppose if there is some rotatory part of that machine, if your hand touch that rotatory part of your machine, then your hand may get damaged. Okay. So with this process chart we can eliminate or we can reduce those unwanted movement. At the same time, if suppose if the, after recorded the process chart and 200 process chart, if you see that some movement we can change. Suppose one movement we are doing now, we can do that at the beginning, so that the process will be in a sequence and time taken for that process will be reduced. Okay, so for those cases we can rectify that and we can reschedule the movement. So that's it is written. The objective of this investigation is to eliminate or reduce the unwanted motions and to arrange the remaining motions in a best sequence. Okay. Next, a 200 process chart is made up of two columns in which the activities of the left hand and right hand and the appropriate symbols are respectively recorded in sequence. So, two column we have made. In the left column we have wrote like a left hand job, then right hand movement. In the right side we will write right hand movement, and we indicate using different symbols like symbols of operation, symbols of delay, movement, etc. And also we will write about the activities, and that is done in a sequence. At the sequence it is actually carry out. Then the activities of the two hands are interrelated by aligning the symbols on the chart so that movements by both hands appear opposite to each other. So the activities of two hands are interrelated by aligning the symbols on the chart so that movements of by both hands appear opposite to each other. So in a one column we will write the about movement or whatever the process, whatever the activities by the specific symbol, and the right side will write at the at that time period what our right hand is doing with appropriate symbol, right? So that we can have an idea at that time specific time period what our left hand is doing and our right hand is doing. Then additional column can be designed to record the activities of the other parts of the body whenever necessary. Suppose with the hand movement, sometimes our another body parts also need to move. Sometimes we need to bend, sometimes we need to close our suppose not close, we need to tilt our head. Okay, sometimes we need to go down, we need to sit, sometimes we need to stand. So all those things are activities by other parts of our body. So if it is required, we can make a separate column and we can mention that. Mention of the activities by other parts of our body if it is necessary. So now let's just see an example. See, so this is a two hand process chart. Some example, real example. So here at the top, you need to write what is the operation, operator name. Okay, it's nice. Yeah, their number, which part, then effective time for left hand how much time, right hand how much time, ineffective time, and total cycle time. Okay, method cycle, method is it is already available. Those a freehand sketch also, simple freehand sketch if needed you can draw here. So here if you can see there is two column, one is left hand description, another is right hand description. Okay, and in the middle we have shown the activity symbol and how much time is needed or used for that activity, both the left hand and right hand side. So here if you can see the what is the operation? Operation is fixing screw on assembly. In an assembly we are fixing a screw, the date time. Okay, so in that the analyzer, the analyzer name is also there, the analyzer need to write down all those things. So he will write that in left hand, what left hand will do, he will pick screwdriver from rack, left hand will pick the screwdriver from the rack. So means it is a movement. He is taking it and handing over to, at that time period what you will do, insert screw in hole. So when your left hand is picking your screwdriver, picking the screwdriver from the rack, what your right hand will do, the right hand is doing, it is inserting screw in particular hole. Then next is here is symbol means, and you can see the arrow symbol, it is opposite to our right hand, means our left hand is going away from our right hand, right? The next activity is bring screwdriver to screw, means we have taken the screwdriver and now our left hand will take the screwdriver and will take it to close to our right hand. That's why the symbol is in right side, in right hand side. Okay, and means after picking the screwdriver he will take this to the screw so that they can tight it. Then at that time period our right hand will be ideal because he already insert the screw. Now the right hand don't need to do anything. Okay, next is the third, tighten screw. Some operation is going on. By left hand we are tightening the screw, and at that time period we are, our right hand is holding the screw to hold so that easily the screw can touch to the hole. So and this time period, see you can see rightly it is written how much time is written. This is in second, 1 second, 1 second, 5 seconds. So the same summary has been written here. So for left hand, how much total time, effective time? It is 1 plus 1 plus 5 is total 7. 7 second effective time. What about the right hand? 1, as it is not effective, hand idle means this is not effective. So 1 plus 5. So total 6 second the effective time. Then ineffective time, there is no ineffective time for left hand, but there is 1 second ineffective time by the right hand. So that we have written here. And what is the total cycle time? Total cycle time is 7 seconds. So these activities is done by our left hand and right hand for 7 seconds. So duration of the this operation is 7 seconds. Okay. So understood this how this two-handed process chart will work. Any question in that? Any question? So this is a real uh, process chart. Okay, two-handed. So see now this is for just some operation. So again this is showing the task means you are signing a letter means you need to sign a letter. So at that time period, what your left hand and right hand doing? If you are a right-handed person, this you will sign by using a right hand. So if you can see here, all the time your left hand will need to hold the letter. So by using left hand, just imagine with your left hand we are holding the letter, and by using right hand, what we will do? There is some operations, sequence of operation is there. So first we need to reach to our pen, our hand movement. Then we need to take or grasp the pen. See, there is some operation. So more, you can say more larger circle means you can say time period is more. Then we need to carry pen to paper. After carrying the pen, we need to take close to the paper. Then signing the letter. Then next operation is return pen to holder. After signing is over, we'll hand it over to the holder. Then release pen to the in holder. After going to hold position, we need to release the pen. Then again, we will take our right hand to our and back to the letter. So this is a task which is known as signing a letter, and how your left hand and right hand will do. So in that way, our left hand and right hand will work. So in with the symbol we have present the task. So understood the how this left hand and right hand will work. This is a two-handed process chart for signing a letter. Any question in that? Again, the thing which related the things same type. Any other another task. Okay. Task is assembly of nut and bolt. So here more detailing it is shown here by the symbol also. It is showing that how much time is required for uh, operation, for movement, some hold or storage, and some delay. So to assemble a nut and bolt, what is the procedure? That is described here. So our next mm, chart is multiple activity chart. So what we will do in multiple activity chart? In this particular type of chart, the activities of more than one item are recorded on a common time scale to show their interrelationship. So here in multiple activity chart, uh, uh, we the man machine both can be involved. Before we have checked different types of chart, and in that chart we have seen that this chart, due to activities by the machine, by the equipment, or by the operator. But in multiple activity chart, both the things can be recorded. Means multiple activities. Okay. Like one example is man machine chart is a type of multiple activity chart. So there are different types of chart are available. The types is been written here. Types of multiple activity chart, like man machine chart. So here in this chart, one man is operating a machine, okay, or operating a job. So that is called as a man machine chart. Then man multi machine chart. Here one operator, one man, he is operating multiple numbers of machines. More than one machine he is handling, or more than one job is handling. Then machine multi, then man chart. So here uh, a group of, or a gang, or a number of worker, they are collectively doing one job. So as an example, like riveting. For riveting, suppose one is holding the plate, another is taking the uh, nut and bolt, or you can say the part equipment through which we need to rivet, and another is worker is actually doing the riveting. So a group of people collectively doing some work, doing one job, but one particular job. Then another thing can be possible, like multi man machine chart. So here a number of person working on a computer system. So here man numbers of are more than one, machine number also more than one. So we have a group of people who are collectively doing in a group of machines, or for a group of machines, or a group of, like suppose computer system. So multi-man machine chart. So four type of multiple activity chart are available: man machine chart, man multi machine chart, machine multi man chart, then multi man machine chart. So let's see more about multiple activity chart. In it, the activities of more than one item, worker, machine, or equipment are recorded on a common time scale to show their interrelationship. Okay, so more than one activity, that may be regarding to the machine or equipment or item or worker. Okay, that is recorded in a common time scale to check or to analyze the interrelationship between them. Then it is used when a worker operates a number of machines at a time. It is used when a worker operates a number of machines at a time. It is also used when a number of workers jointly do a job, means a group of people collectively doing some work. So why it is needed? Multiple activity charts are very useful tool for understanding the flow of work in a cyclic process, and as a consequence, understanding which resource is controlling the overall progress of the work. So with this multiple activity chart, we can understand the flow of the work, okay, in a cyclic time. Also, we can understand how the resources control the overall progress of the work. So the tool can be used to model different scenarios to determine the optimum mix of resources for the work. So how optimum way we can use our resources. So the purpose again, to detect the idle time on machine and workers, to optimize work distribution between machine and workers, then to decide number of workers in a group. As we are, if suppose a group of people are working on a, what I can say, on a machine. So how many worker is needed, that we can decide using multiple activity chart. Then we can have a good balance in a team. We also examine the activities. It is used for recording the complex movement of material or man, used to find out the most economical route or most resource optimized route, which is most economical way. Okay, so these are the purpose of multiple activity chart. So what is the application? Application like plant repair and maintenance, job construction, planning teamwork. Again, it is used to check whether the workstation is correctly located or not. So these are the application of a multiple activity chart. You can plan other to repair and maintenance, when repair is needed, when maintenance is needed. You can plan the job construction, the teamwork can be planned. Also we can check whether the workstation is correctly located means workstation is workstation location is correct or not. Those things we can check. Okay. So one example has been shown here. So suppose this is operator and machine 1 and machine 2. Okay. So load cloths and detergent in machine 1. It is done by the operator. So at that time machine 1 is loaded, so it is written being loaded. At that time machine 2, which is a dryer, it will be idle. Then operator will be idle and machine 1 will work. It will run. At that time machine 2 dryer will be idle. Then remove cloths from machine 1. Operator after operation is over, we need to remove the cloths from machine 1. Students, don't write your roll number in the chat box. I will not count it. So then okay, so remove cloths from machine 1. At that time machine 1 will be unloaded. Till now machine 2 will be idle position. Then next machine 2 will work. So we need to load cloths into machine 2. So machine 1 will be idle and machine 2 will be loaded. Then load cloths and detergent into machine 1. Again machine 1 will be loaded, and that time period machine 2 will run. So next is operator will be idle, and then machine 1 washer, which will wash the cloths we have loaded in the washer. At that time period machine 2 also run. So it is drying operation is over, then we need to that take out the cloth from the dryer. So it is being unloaded. Then hang cloth, both the machine washer and machine dryer is idle. So in this uh, multiple activity chart we can have idea at the same time scale what a operator or machines is doing. It is whether it is running, some operation is going on, etc. We can find out using this multiple activity chart. So multiple activity chart, the same thing. It is how much duration it is there. It is written this way. Whether machine will be idle, what we need to do when operator is idle. Those things has been written. So here you can see in summarized way, for operator cycle time is 1.96 minute. Then time work per cycle, it is 0.46. Then percentage utilization, this that percent, and machine utilization is 76%. So you can have idea how much your machine or operator is utilized. So this is multiple activity chart for machining of a component, that task. Okay. So today up to this up to the multiple activity chart, and next class we will see different other types of chart. So if you have any question, you can ask me now.